Hello and good morning to everyone. I thank to all of you for attending such an important safety training in NFPA 70E. I specialize in NFPA 70E and 70B training such as arc flash protection, shock protection, its risk assessment and selection of PPEs as well as trainings in electrical safety program and electrical maintenance. Before going to start our today's session, I would like to introduce myself. My name is Rais Malik. I did BE in electrical engineering from Mehran University of Engineering and Technology Jamshoro, and I registered as a professional engineer in Pakistan Engineering Council. I got top position in my university along with the medal and certificate of achievement. I also won departmental scholarship each year in my university because of my excellent academic record. I have also 13 years of comprehensive experience in electrical power control and automation, electrical maintenance, electrical asset integrity and reliability, electrical projects and planning, and I also worked as a SAP electrical planner. I also served in top-rated companies in Pakistan such as Fuji Fertilizer, Sinengro Coal Mining Company, National Refinery Limited, and recently working in Prime Global Energies XENI Pakistan. I have also obtained and achieved 150 plus trainings and certifications in electrical power, control, automation, electrical maintenance, project management, budgeting, maintenance planning, quality management, electrical and plant safety awareness, as well as key soft skills. I also won HSE Leader Award in 2025 at Prime Global Energies and Safety Slogan Award in 2017 at Fuji Fertilizer FFC. That's all about my basic and detailed introduction. Now let's come to our main topic, that is NFPA 70E clause 130.5 that belongs to arc flash hazards, its risk assessments and selection of arc flash PPEs. Now, what is an arc flash? An arc flash is a dangerous release of the thermal energy caused by an electric arc. It occurs when an electric current leaves its intended path and travels through the air between conductors and from one conductor to the ground. So the arc flash results in extremely high temperatures that is exceeding 35,000 degree Fahrenheit and 19,400 degrees Celsius. That is four times the temperatures of the sun's surface. Arc flash can also produce intense light waves in the wavelength of ultraviolet and infrared radiation lights and emit lights such as in electrical arc welding that can cause damage in the eyesight, retinal damage, as well as temporary or permanent loss eyesights. Arc flash can also create violent molten metals and projectiles. That is 1 inch of copper vaporizes into 67,000 particles and sharpnels that can create first, second, and third degree burns to the human body. Further, arc flash can also produce rapid expansion of the air. That effect we call is blast effect. That can cause lung damage, bone damage, and can throw the employee several feet away from the workplace. Further, arc flash can also produce a sound energy that is equal to or greater than 140 decibel that can cause eardrum rupture, injuries in the ear, as well as temporary or permanent hearing loss. Now, what is an arc flash? As per NFPA 70E Article 100, an arc flash can be defined as a source of possible injury or damage to the head associated with the release of energy caused by an electric arc. It means that any task performed near electrical energized equipment may create or produce an arc flash. And such condition is considered to be an arc flash hazardous condition. Example of such hazardous condition are that a person working on energized conductor greater than or equal to 50 watt, or an electrical technician that is raking in and out the circuit breaker, or a qualified electrical person performing troubleshooting on live parts, or a competent electrical person opening electrical panels with energized components, or an electrical supervisor removing boards covers from switch gears that is consist of electrical power cables and electrical components. Now further we have to discuss how to identify arc flash. As per NFPA 70E clause 130.5a, it explains the process of identifying electrical hazards, specifically arc flash hazards. The main focus is on determining whether an arc flash hazard exists, and if it is to be exist, then what conditions or factors that contributes to it. So when we will have to go for identification of hazard, we have to know in what equipment we are going to work, such as electrical motors, transformers, generators, electrical lighting systems, switch gears, MCCs. So accordingly, we have to analyze it and divide the main job into activities and then activities into subtasks. And we have to analyze each task and evaluate the hazards hidden in it. So these are some key steps in evaluating the hazards in any electrical job. Number one, identify if the worker will be exposed to energized part. Number two, evaluate if normal operating condition exists or not. The third one is identify tasks or the critical task that increases arc flash exposure. Further, identify equipment with a potential of arc flash, such as electrical motors, switch gears, contractors, reed breakers. And also, we have to evaluate system electrical parameters such as fault current, voltage, protection devices settings, and working distance. Further, we have to identify the environmental conditions or the conditions of the equipment that increases our ignition potential. And we then finally we have to document all hazards findings for further analyzing and assessment. How to identify arc flash hazards? So there are four columns. The first column is the steps. The second one is to identify key hazards. And in the third column, we have to brainstorm and we have to analyze the key hazards, and certain situation. And the fourth column is the outcome of the results of the situation. Number one is exposure to energized part. Determine if work involves contact with energized conductor or circuit part. Will the worker be exposed to energized parts or it will be working on the energized part? Secondly, if it is working on energized part, then can it be possible to energize the electrical live parts? Then the outcome is if no exposure to electrical parts or the person is working in de-energized system, then no arc flash hazards. If person exposes to live electrical parts, then the risk assessment might be continued. Second is to check normal operating condition of electrical equipment. Confirm equipment is in safe operating condition, and you have to ask and analyze if the work equipment is properly maintained or is it properly installed or are the doors and covers secured or there are no signs of damage or of overheating. If it founds normal, then there is a no arc flash will. But if there is an abnormality in the electrical equipment or system, then the arc flash may likely to be occurred. The third step is task evaluation. Identify each activity and task that can contribute to arc flash hazard. Is it the task invasive or non-invasive? Does it involve opening covers, testing live circuits, checking parameters, breaking in and out breaker, removing electrical panel? Determine likelihood of every task that contributes to the initiation of arc flash during the task. The fourth one is equipment type identification. Identify equipment prone to arc flash. You have to identify the equipment is motor, transformer, switchgear, MCC, HV switchgear, LV switchgear, and what are its high fault current or what is rated fault current. As if the fault current is higher, then there might be a possibility of higher arc flash energy. So outcome is certain equipment has higher hazard potential. The fifth one is electrical system characteristic. We have to understand systems electrical parameters that is contributing in arc flash, such as available fault current, fault clearing time, voltage level, and working distance. Such type of inputs are very useful in analyzing arc flash studies according to IEEE 1584. Then hazardous conditions. We have to identify environmental or abnormal conditions of the electrical systems around the electrical equipment that may trigger arc flash. We have to check any dust, corrosion, moisture, loose connections, old or properly maintained equipment, evidence of any tracking. Such abnormality increases the probability of an arc flash. The final is the documentation of the hazards. We have to record every hazard that can create arc flash. Then, does the task plus equipment and conditions create an arc flash hazard? If it's so, then we have to perform a full arc flash risk assessment as per clause 130.5b. If not, then the equipment can be maintained or then the work on that equipment can be done safely. Now we have to discuss arc flash risk assessment. What is the methodology of arc flash risk assessment? As per NFPA 70E, at a high level, 130.5 requires that before any work is to be done, there is an arc flash hazard. A formal risk assessment is to be conducted. It is an approach of systematically identifying hazards, evaluate risk, performing its risk assessments, and then define protective measures, including PPEs, work practices, boundaries, and electrically isolated LOTO procedures. So, the methodology contains 130.5A, that is identification of arc flash hazards, 130.5B, that is estimation of likelihood and severity of injury, 130.5C, determination of additional protective measures, 130.5D, the documentation, 130.5E, arc flash boundaries and specifying it, 130.5F, R flash PPE requirements and its selections. And the 130.5G, calculation of incident energy and incident energy analysis method. 130.5H, and finally having a label on equipment to aware the electrical person of any type of hazards or related to such equipment. By formalizing the risk assessment, 70E ensures that our flash risks are proactively measured or managed rather than reacted to. Now we have to discuss with arc flash risk analysis. 1305B explain how to perform an arc flash risk assessment. After it has been established that an arc flash hazard exists in doing a job in any electrical equipment or electrical system. This clause focuses on evaluating both severity and likelihood of an arc flash while performing a job on any electrical equipment and determine and define how to determine incident energy, arc flash boundary, and necessary PPEs. This ensures that the worker understands the level of danger and what protection is required. The risk assessment might and must evaluate the overall hazard risk considering equipment condition, maintenance history, evidence of impeding failure, type of task, invasive, non-invasive. Risk assessment to be reviewed whenever equipment condition changes, work procedure change, new information or hazards becomes available. And our flash assessment must be reviewed every 5 years, which indirectly requires updating risk assessments. Our flash risk evaluation. For evaluating the arc flash risk, we have to use a risk management system, that is risk metrics based on ISO 31000 within the latest edition of 2018. NFPA simply encourages to use two-dimensional metrics, that is risk to be calculated based on likelihood and severity. Likelihood levels is the qualitative used according to task and equipment condition from informative annexure F, that is purely based on risk management systems and principle, that is ISO for 31000. And the severity level is based and evaluated by incident energy or PP category. So in the vertical columns, there is a likelihood and it is divided into four types. That is very likely, likely, possible, unlikely, and very unlikely. And the horizontal row defines the severity, that is low, moderate, high, and critical. We have to analyze every risk on the basis of this matrix and to control it. as per hazard control methods such as elimination, substitution, engineering control, awareness, administrative control, and the final defense line, that is PP. What are the requirements of our flash risk assessment? Why we have to need to assess the risks with using such risk matrix and ISO 31000? The first is to determine our flash boundaries. We have to identify the incident energy and calculate it as per engineering analysis, and we can refer it through NFPA 70 table. After evaluating such incident energy and defining arc flash boundaries, we have to establish safe approach distance and define restricted area. Secondly, determine incident energy exposure. We have to calculate incident energy based on IEEE 1584 or validate method, and can refer also to NFPA 70 table only if equipment matches table parameter. Determine severity of potential injury and required PPE rating based on such incident energy calculation. Then select arc related PPEs. We have to choose arc related PPEs by using two methods. One is energy incident energy method, match PPE rating greater than or equal to calculated energy. Or other method is PPE category method, category 1 to 4. Ensures worker protection from thermal arc flash energy. Identify safe work procedure. After analyzing and assessing the risk, we have to control all the risk, and based on energized work permits, establishing boundaries, using insulated tools, engineering control, reducing risk to an acceptable level during energized work. Apply R flash labels per 1305.g. Equipment must be labeled with incident energy or PP category, and define R flash boundary, working distance, rated voltage, ensures official and critical information is available at point of line. Now, the final is the arc flash PP and its selection. As per clause 130.5 F and G, arc flash PPs must be selected based on number one incident energy and number two PP category method. Arc flash PP is required if the worker is to do job or can need to enter in the arc flash boundary. So according to NFPA 70E table 130.7 clause C subclause 15C, there are four categories that are defined by NFPA according to the incident energy. Number one is category 1, that requires 4 kilocalorie per centimeter of incident energy, and typical PPs are rated shirts and pants, facials. Category 2, when the incident energy is equal to greater than 8 calories per centimeter square, then typical PPs are clothing, arc baklava, or hood. Category 3, when incident energy is greater than 25 calories per centimeter square. Category 4, when incident energy is greater than or equal to 40 calories per centimeter square. Then the PPs needed are arc flash suit, hood. So that's it from our today's session, where we have discussed arc flash, define arc flash and hazards as per NFPA 70, determine the method to evaluate arc flash hazards. Based on such identifying hazard, we have evaluated the risk and perform risk assessments using the risk matrix. And then on the basis of incident energy and PP category, we have discussed how to select our flash PPEs. So thank you, goodbye, and have a nice day.